Hi, Marion County students. It's Mrs. Suter, and I'm back again. Today I'm in my office and not in my kitchen. We're going to be working with the electromagnetic spectrum. We are going to do a project at the end, or kind of in the middle, I guess, talking about the electromagnetic spectrum and how we can view the electromagnetic spectrum through a tool that we will make called a spectroscope. So I'm going to share my screen and we're going to go into a presentation of the electromagnetic spectrum. So here you can see the electromagnetic spectrum. This right here, this picture is a plasma ball, and we're going to talk about it and how it shows the electromagnetic spectrum. But that'll be after we build our spectroscope. I'll show you about the magnet ball, or this plasma ball. Okay, so let's go here into what the electromagnetic spectrum is. Well, the electromagnetic spectrum is the electromagnetic waves. And they're energy waves, and these waves are special because they both have an electric and a magnetic field. Now, as you can see over here, these are our electric fields, okay? So if I have a positive and a negative, they attract and pull together here, and the electricity will flow in this circular pattern. The electrons or electricity will be flowing in through this negative side, and then here they will meet up, and they will flow out through the positive side. Now, if you put two positives together, it will not work because they will repel. But if you put positive and negative together, it will attract and the electrons will flow. Same thing for magnet. We have a north pole and a south pole, and these two are attracted. So when they are joined together, you can see that field there. Again, we have the field coming in through the south pole and out through the north pole. If I try to put two north poles together, they will repel or pull apart. Same as two south poles. So electromagnetic waves both have electric and magnetic field, which makes them very special and very useful for things that will be for communications and medical fields. Okay, so there are two different types of waves. We have electromagnetic waves and we have our mechanical waves. Now, mechanical waves you can see in the world, like if you would drop a stone in the water, you could see the ripples or the waves traveling through the water. If you have a slinky and you would shake it, you could see the waves traveling through. Those are mechanical waves because they have to travel through something like through air or through water or metal, those kinds of things. So sound waves are in there, and water waves, those kinds of things. Now, electromagnetic waves do not have to have a something to travel through. They can travel through a vacuum, which that's why we love them, because they can travel through space where there is no air, there is no other substances. Okay, so the electromagnetic spectrum, you might think, well, why do I even care? How does this apply to me? Well, it applies to you because in your daily life, you may experience most of these waves throughout your day. So here's a scenario where you will experience almost all of the waves in the electromagnetic spectrum. So you are lying in bed when your alarm clock goes off. You get up and you feed your fish when you notice the light from the window is creating a rainbow in the corner of your fish tank. You head downstairs to the kitchen. As you enter the kitchen, you use the remote control to turn on the radio in the kitchen as you pop a breakfast burrito into the microwave. While waiting for your burrito to cool off, you look at your cell phone for any messages. After eating and getting ready for school, you head out on this sunny day to wait for the bus. In this scenario, you have experienced almost all of the waves in the electromagnetic spectrum. So you have had ultraviolet, UV rays, you've had visible light rays, you had radio waves and microwaves, and you've also had infrared waves. So we're going to talk about all those, but in that scenario right there, you have almost all of them. Now, if I would have added in there, you went to the dentist and had an x-ray of your teeth, then you would have had almost all of them. We would only be missing gamma rays. So we'll be talking about all of those, okay? Now, we talk about waves, any kind of waves at all, we use the word frequency. And frequency is how many waves are traveling over a certain amount of time. Amplitude means how big the waves are, And then the frequency is how many waves can go through a certain amount of time. So if my waves have a big wavelength and they're got this wide wavelength here, we don't get as many going through. So this one right here has about 2 waves going through in this amount of time, which we could say is 1 second. So it have 2 waves. Now, and these don't have a lot of energy. They're traveling slower. But if we have medium frequency, we get more waves in that amount of time, and they have a shorter wavelength. So here I've got at least 1, 2, 3, and probably a half, 3.5 waves going through this about 1 second time. Notice that the wavelengths are smaller, but I get more waves in that amount of time, and we say this would be a medium frequency. Now, high frequency, you see how short the wavelengths are. They're very small, but I get a lot of waves in that amount of time. So I get 1, 2, 3, 4, 5, 6, 7, about 7 waves in that 1 second time. So we would call this a high frequency. They have short wavelengths, but a lot of energy because we got a lot of waves going through in that 1 second time. So we're going to be talking about this word frequency. The lower the frequency, the less energy. The higher the frequency, the more energy is going through. Okay? So when we think about waves, we have this PhET simulation. This is probably one of my favorites to talk about waves. So if you want to play with this at home, you just go on to PhET, P-H-E-T, simulations, and this one's called Wave on a String. So here I have a wrench and it's holding my string of beads. Now I can move here and you can see the energy traveling through my string, my beads. And this is creating some waves. Now, I'm not very smooth when I'm doing this, so I might want to come back down here and change and make this an oscillating so that it's moving on its own at a very smooth. Now I can see my waves traveling through my string of beads. Down here is the frequency, which is called hertz. We measure in hertz. So we're saying this is about 1.5 hertz, which means we get about 1.5 waves going through here per second. Okay. Now I can increase my frequency, make it higher. So I can take this and put up here, and now you can see that I get a lot more waves going through my string of beads in that amount of time. So we would say this is 3 hertz, more energy. You can see how fast my oscillating gear is going there. Now I can also slow it down so that it's barely moving at all. So I've got a very slow, less amount of energy going through, very few waves. Okay, so I can play around with the frequency, and I can also play around with the amplitude. If I wanted to go, if I turn on my ruler, you can see right now it's going up about half an inch or so. And now if I want to make it go higher, I can make it go up higher, and then you see that my waves, the amplitude has gotten a lot bigger. Okay, I can even slow it down so that they go a lot less. Okay, I can also work with my dampening, so I can dampen it so that it's stiffer and we don't get as much going through. And I can work with the tension. Right now I've got a pretty high tension, but here you can see, if I get a low, you can see how the beads now separate, and that changes my how many waves are going through there because of the tension. Okay. Now I'm going to change, go back to my medium tension there, and I'm going to change this over here to have a loose end. So you can see now that my loose end is still moving and they're traveling, but notice that the wavelengths get smaller as I go. So if I have no dampening, then you can see that I've changed that and I get a lot of movement in here. Okay, I'm going to come back down here to my dampening a little bit more. Okay, now I can also do a no end where you can see that the waves are going to just travel right through the air there. So you can play around with this. We also have a pulse where I can make it pulse and I can change, and you can see how the wave would move. All right, there's also a timer you can add and your reference line so that you can see how high they would go. So these are all things that you can play around with during when you get off get off this presentation, you can get on a PhET simulation, play with some waves. Okay, now, the electromagnetic spectrum is right here. These are the parts of the electromagnetic spectrum. We start with a very long wavelength, so we say a low frequency up to the highest frequency. Remember, the lower the frequency, the less amount of energy is being transmitted through there. So down here on the lowest end, we have radio waves. And radio waves are how we get radio and TV broadcast to our home. Microwaves get a little bit stronger. We get telephone signals from your cell phone and cooking and radar for microwaves. Infrared is the transmission of heat. So when you're cooking and those kinds of things, radiators. Visible light, this is the things you're able to see with your eyes. Ultraviolet light is what comes from the sun. It's harmful, so we want to wear sunglasses. And then we have X-rays and gamma rays. Now, the higher up we go, the more frequency, therefore, the stronger, the more energy. Now, these three rays right here can actually penetrate your skin, and they can damage your soft tissue in your body. So we have to be very careful with these because they can be very damaging to your cells in your body. So we have to make sure we have lots of precautions when we are working with ultraviolet X-rays or gamma rays. Okay, so to go on here, radio waves, I said, have the longest wavelengths. They have the least amount of frequency, the least amount of energy. And we use those to transmit radio signal through the air or through space, and also television. Okay? We also use radar to determine where airplanes are in the sky, or submarines or ships, so we can use radar. And we also use it to, like I said, transmit from satellites. So when we're getting information from satellites, they're sending it through radio waves. Okay? Now, a little higher up on the frequency, we have microwaves. Microwaves help us to get our cell phone reception. So these are microwave towers that help your cell phones send and receive messages. We also use them for cooking, and we use them for weather forecasting. So we can use them to tell storms coming through, how much cloud cover and rain, winds, those kinds of things. So radar for weather prediction is through microwaves. Now, microwaves are great because they will travel through smoke and clouds and rain. So they're not blocked from those kinds of things, which are really good in our area because we get a lot of rain, a lot of clouds. Now, move up a little bit higher, we get infrared. Infrared is like heat that is coming off of different substances. So if you are lost out in the forest and it's dark and we're trying to find you, we can use infrared cameras to determine where heat is coming from. Because since your body produces heat, when we use an infrared camera, we can see this red area is where your skin is the hottest, where more heat is generating. Yellow is a little less, and then we get the green and the blues being the coldest. So we can find people using infrared cameras to determine the heat. Okay, snakes can see in infrared. They can detect heat. That's how they can find their prey. So if they're looking for a mouse, they can actually see if the mouse is dead or alive, because if it's dead, it's going to be all blue because it's going to be cold. If it's alive, it can see this pink and red to know that there's heat coming from it, so it's probably something living or giving off heat. Okay, so infrared light helps us to take a look at heat, and also we use it in our remote controls to turn the TV on and off and change channels. Now, visible light, this is where we're going to be building our spectroscope to see visible light. Visible light, most of the visible light we see is white, but white light is actually not white light. It is a combination of all of the colors, and we're going to show you that here at the end of this. But the spectroscope we're going to build breaks apart the white light into all of its colors, because visible light has actually all of these colors: red, orange, yellow, green, blue, violet. Okay, these are ones you can see. All right, and that's the order you see them in. Red, right here, has the longest wavelength of the colors. Okay, and so it has lower frequency, and purple has the highest frequency. So as I go up, they get a little higher in frequency. And so when we break these white light down into, when we refract it and reflect it off of different things, we can then see the different colors in white light. So again, red, shortest, to violet, which is the higher frequency, okay, lower frequency. We can also use prisms to refract the light so that we can see the different colors as well. Now, if we go up a little bit further, we go to ultraviolet light. Ultraviolet light is the light that comes from the sun, and this can be very dangerous to our skin because it'll penetrate our skin and hurt our soft tissue. So that's why we talk about never looking directly at the sun, because the ultraviolet light will come into our eyes and damage our eyes. And if you spend too long outside without proper clothing on in the sun, you can get sunburned. So clothing will protect your skin. So make sure that if you're outside, UV light is blocked by clothing. So we do use UV light to sterilize. You can see here that we are sterilizing or killing the bacteria and off of our medical equipment so that everything is sterile and clean. We use infrared light to do that. We also use infrared light to grow plants indoors. So if we have to grow things inside, we use UV light because it's like the sun, and that's what the plants need to create their food. The Hubble Space Telescope out there in space, taking its great pictures of those planets, uses ultraviolet light also. Now, some animals can see UV light. We are not one of them, but bees, butterflies, small rodents, birds, bats can all see UV light. So that's kind of just an interesting fact. Now, if we go on, we get X-rays. X-rays have the second highest in frequency, so a lot more energy. They will penetrate our soft tissue like our skin and our muscle, and so we can use them to see the bones. They do not penetrate bone. They are stopped by the dense material of our bone, but we can look then to see if the bone is broken. So if you get hurt and you go to the doctor and you have to have an X-ray, they're going to be looking at your bones to see if anything's broken, because X-rays will penetrate your muscle, penetrate your skin, and be looking at your bone. If you go to the dentist, they'll take X-rays so they can see your teeth. It'll penetrate your skin and your gums so they can see if you have anything wrong with your teeth, if you have a cavity or need a filling. We can also use X-ray to treat cancer because it'll kill cancer cells. So we have to be careful though with X-ray because it can damage other parts of your body. And so whenever you get an X-ray, they do cover up the rest of your body that you're not getting X-rayed with a lead vest or something like a lead blanket to protect your soft skin, your muscle and your skin from the X-ray. Now, the highest we have is gamma ray. The highest frequency of wave is the gamma ray. Gamma rays have the shortest wavelength, so the most energy, and they are strong enough that they can go through almost anything. It'll take about a 3 to 4 foot thick concrete wall to stop a gamma ray. So we have to be very careful with them. Gamma rays are produced when a star goes into supernova or explodes. So we get gamma rays coming off of supernovas in the sky. We also use gamma rays if we want to see inside your brain to diagnose a medical problem. We can use gamma rays to help us to see that tissue in there. And we can also use it for treating cancer. But again, we have to be very careful with it because it'll damage other soft tissues. We also create gamma rays when we do nuclear reactions and nuclear bombs, and they are extremely dangerous and produce some radiation. We need to be very careful. So as you can see here, we have our highest frequency of gamma rays. So now what we're going to do is we're going to build a spectroscope. So materials we need are our CD, an old blank CD, some dark construction paper, and either a toilet paper tube or a paper towel tube or some kind of cardboard tube will work. I'm also going to be using scissors and a craft knife and tape to make mine. So if you want to see this step by step, I do have it in my presentation here to show you exactly the steps we're going to go through, but I'm going to switch back here in just a minute so that we can see how we're going to build it together. So I'll come back to my presentation here in a little bit, but we're going to go ahead and build our spectroscope. And here's my paper towel roll. You can use a toilet paper roll as well. I have my CD here, I have my dark construction paper, but as you can see, I've already cut out my circles, so I'm trying to save a little bit of time here. I'm also going to be using my X-Acto knife or my craft knife and my scissors. If you're going to use your craft knife, you need to make sure that you have an adult with you because they can be dangerous. You can get cut. You don't want to cut through a table or through your fingers, so I use a cutting mat so that when I cut, I'm not going to cut into my table or into anything like my leg or my fingers, so be very careful. Okay, so to make our spectroscope, what we're going to do is we're going to be using the CD because it has that mirrored surface to reflect the light, and that's what we want to do. Okay, so we're going to start off with my toilet paper tube, and I'm holding it vertically, and I want to create a slit there so I can slide my CD down at about a 45-degree angle, so down in like that. Okay, so what I'm going to do is I'm going to start off and say I'd like my slit to my CD to start off at about right there. So I'm going to start my slit through my cardboard. Now, notice that when I slide this in, I'm going to want my CD to go down at about a 45-degree angle. So I'm going to create some lines here to pull that slit down so that I can put my CD, slide it down in there. And I'm going to do that on both sides. Okay, so see, I've got my nice there so that I can slide my CD right down in there. Now I want the mirrored side up. I don't want the side that has the writing on it. Okay, so I'm going to slide it down in there so that my mirrored side is facing up. That's where I'm going to be reflecting my light. Okay, now I've got my CD in there. Now I want to have what we call a viewing hole, a little hole on this side so that when I look inside, I can see the light reflecting from the CD. Okay, so I'm going to cut a little viewing hole for myself. Now I'm kind of bad about making circles, so I just usually make a little square because that works just as well. I'm going to take my CD out for a minute so I can put my tube down. Because I don't want to get hurt. And I'm using my cut mat over here so that I do not hurt myself or cut into the tube or my finger or anything like that. So here's my little viewing hole. I'm just going to pull that piece out. Okay, so there's my little viewing hole. And here's my slit on the other side. So I'm going to slide that down. Now when I look in here, I can see the light reflecting off the CD. Now, you can't see it because it's dark in there, but I can. Now, I also want to cover up this part of my CD or of my tube so that I'm just really focusing the light. So what I did was I took a pencil, I just traced the circle here so I'd know how big, and I made it a little bit bigger than that so it would go over top. And then you can see I cut a little slit in there, so that's where the light's going to come through and hit off my CD. Once I have this cut, I'm going to take my CD out for a few minutes. Then I'm going to tape it up there on the top so that the light can flow through just that little slit. Now, I'm not going to be stingy with tape. I'm going to try to get it to tape so I can hold that on there. Pretty nice. But you also need to be careful that you don't cover up that hole with the tape. I've done that before, and I didn't like having to take it all apart again. Okay? So try to make sure that you don't put tape over top of that hole because that's where the light's going to come on in, and you don't want to have the tape blocking it so that you lose some of that really pretty spectrum, the visible light spectrum. Okay, so got it taped on there. You might want to tape it more, but I've got mine in there. Now I'm going to take my CD. There's the top. Take my CD, slide it in my slit. Now, I can use this two ways. I'm going to take my glasses off here. Look in this way. Oh, I got a really nice red, green, blue spectrum. I'm looking, must be seeing this light. Oh, and I can even point it down so I can really get an idea of the light there. Okay, I can also turn it sideways and look at the light like this so I can see different lights in my spectrum around so I can see the different light. So inside here, it's actually going to break up that light so that I can see all the different colors that make up that light. Okay, so you're going to see different, if you look at different light, if you look at fluorescent light versus sunlight versus candlelight versus LED light, the spectrum that you're going to see in here, the colors are going to look different. Now, it's going to be the same colors, but different amounts of each one. So you're going to want to take a look at that and write down, like, I'm using a fluorescent light. What colors do you see the most? You draw it out. Look at an LED light, look at sunlight, and then draw out what you see so that I can tell what kind of light or what kind of colors and how much of each kind of light. Okay? Yeah. Nope. And we're going to talk a minute. I'm going to go back to sharing my screen and talk about why it works. Okay? So let's go back here to why it works. So why it works, works is because, like I said, that CD has that mirror surface, and it has grooves or pits or tracks, whatever you want to call that, in the surface, and they're evenly spaced. So what happens is it diffracts or breaks up the light so that you can see the different colors. So that mirrored surface with those grooves in it is how the light is reflected to your eye so that you can see the light better. Okay? Now, I also included in my presentation a nice article on how we see light, which talks about the different kinds of light, the different colors of light, and the electromagnetic spectrum. I also included at the end of it a little video, which you're not going to need to see because I'm going to include it in this part of the presentation anyway. So I'm going to come out from sharing my screen here, and I'm going to talk to you again about a couple more things that we are going to want to, I told you I have a couple extras for you. So I'm going to go grab them. I'll be right back. And I want to show you a couple other neat things. So what I have here is got an LED light mixing crystal we want to talk about. And I also have my plasma orb or plasma ball that I want to show you some things about. Okay. Now I told you that white light is made up of different colors. So this right here is what we call a color mixing LED crystal. Now I got this from Tinker Crate, which I get a lot of things from. It's called from Kiwi Company, and you can go to kiwicompanyco.com and you can look for these. But this one is Tinker Crate, and it has a lot of science projects in it. This one, they sent me all the materials and told me how to build it. So you build the cardboard piece, which is real easy. You have your battery box, and then in here's just my plastic crystal. Right up in here, I have an LED. This LED is RGB, red, green, blue, which means it has all three colors in it. You can see that I have my electronics going right here, so that controls the different lights in there. And then up here, I have my metal conducting plate, which conducts the electricity. And you can see I have brass fasteners. So when I come down here and I turn my my little switches and hit the metal, that my light will come on. Okay. Well, I'm going to do this quite quickly so you can see a little better. So in this, what I'm going to do is I already turned on the power in the back, so it's on. Then when I push this down, you can see the red light comes on. Okay. When I flip this off and I turn it to G, now my green light comes on. Turn that one off and turn on my blue light. So like I said, it's RGB, red, green, blue. So I have those lights in there. Now, when I want to mix colors of light, I can create different colors of light. So if I take my red, and then I also mix it with my green and turn on green, you can see that it produces a yellow light. So here I've got a nice yellow light from the red and the green that joined. Okay. Now, if I take my green off and I just go back to my red and I mix it with my blue, here you can see that I've turned to a really nice, pretty magenta color light. So it's kind of like a dark red or a dark pink or a light red. It's called magenta, right? Now, if I turn off the blue and I turn off my red, and this time I'm going to mix the green and the blue, now I get this really pretty cyan color, which is kind of like a teal. It's really a pretty color. So when I mix the green and the blue light, I get cyan. Now, the other question is, what happens if I mix all three colors together? So let's take the red, which has my lowest frequency, okay? Then we're going to take the green. Now I get that yellow, and then when I mix in the blue, I actually get a white light. Because remember how I told you that white light is actually the color, the presence of all colors? When I mixed all three, I get the white light inside. So, make sure I get my blue back on there. So, that is how you get white light, by mixing all of the colors. Now, I'm going to turn these off. If this is something that you're interested in, Kiwi Crate, love it. Anyway, the other thing I told you I was going to show you was the plasma ball, or the plasma. Okay, I have mine here. And the reason that we talk about plasma when we talk about the electromagnetic spectrum is because, plasma orb, is because it has waves in it that are both electric and magnetic. So right now I've got this electric field here, and my waves are coming off. And when I touch it, it becomes attracted to my finger, and I can create the different things. So if I put all my fingers on there, you can see that I am attracting it. Now, that's showing you that attraction of magnetics. But the other thing I can show you is that it's electric. So I have right here a fluorescent bulb, okay? And I don't have it plugged into anything. It's just a straight fluorescent, no plugged into anything. But if I if I just put it above my plasma ball, I can make the light come on because it's transmitting that. And I know you probably can't hear, but there's a little teeny sound of like static when you are doing this, so that you can make the light come on without it being attached to any batteries, or you can, I don't want to hide so you can see that I don't have it attached to anything but the plasma ball. So I can take it away, and when I turn it back on, there you go. All right, so that's a little bit of fun science for you. I hope that you do create your spectrum, your spectroscope, and I hope that you go out and you record what you see, the different light and the spectrum, and that you report back to me. So you can send me pictures, or you can show me your lab sheet where you wrote down like what light we're looking at, candlelight, and you showed me the spectrum that you saw, what colors. Or you sunlight, or remember, don't look directly at the sun, or fluorescent light, or incandescent light, or an LED, and the different kinds of light and what the spectrum looks like in your spectroscope. So enjoy, have fun, and I will be back with you later, and we'll do another science at home. See you later.